of the presentation. Tonight, our presenters are Bob Lilac, Mike Turco, Ron Kelling, and Jim Stinson. Bob Lilac is the president of Mud One. He is a member of he earned a BS degree in mechanical engineering and a master's in industrial certificates in transportation economics from Yale University. For 6 years, Bob has been active in supporting water mitigation and sensible water use. Mike Turco is the general manager of the Harris-Galveston Subsidence District, a special purpose district created by the Texas legislature in 1975 for the purpose of regulating groundwater withdrawal to prevent land subsidence. Mike earned his bachelor's degree and his master's degree in geology from the University of Nebraska, geologist for the United States Geological Survey with studies in areas in Iowa, Nebraska, and Texas, and served as the chief hydrologist for the United States Geological Survey in the Houston office from 2004 to 2013. Ron Kelling has been deputy general manager for the San Jacinto River Authority for 13 years. He earned his bachelor's degree in civil engineering and a master's of engineering from Texas A&M University. He has over 40 years of civil engineering and project management experience. Jim Stinson is the general manager of the Woodlands Water Agency, the management organization for the 10 municipal utility districts that serve the Woodlands in Montgomery County. The agency provides water distribution, wastewater collection, storm drainage, and tax collection services. Jim was appointed as an original board member to the Lone Star Groundwater Conservation District, representing the Woodlands from 2001 to 2018. Jim earned a civil engineering degree from Texas A&M. Go ahead and get started on our very important presentation. And with that, we'll start with Bob Lilac. Bob?
Thanks, Ted. I'm sorry, everybody in the audience, but we've lost some voice here, and that's one of the problems with Zoom. But hopefully you can hear me as we start off here. Can everyone see the screen? Panelists, Ted, can you see the screen okay?
Yes.
I see it perfect, Bob.
Okay, thanks. I appreciate the introduction. I'm sorry everybody didn't hear it all. But we want to start with something that I think is very important to every resident here in the Woodlands and Montgomery County. But before we get started with the presentation by our experts, let me give you a little background. Here, this slide shows the population growth over the last 20 years. As you can see, the population in Montgomery County has actually more than doubled in the last 20 years at a 3.7% compound growth rate. And not surprising, water demand has also increased with the population, but fortunately not quite at the same rate, as the new residents don't use as much water as some of the older residents. So the growth in water demand is about 30% less than the population growth, and the total water demand has steadily increased at a compound rate of about 2.6, 2.7% over the last 20 years. In the year 2015, however, the surface water treatment plant began using water from Lake Conroe, starting in that year at about 35%, increasing at one point to a high as 65%, and decreasing over the last couple of years for a variety of reasons, and now settling in at about 50% of the water that we use in SJRA's territory is supplied by surface water as opposed to groundwater. Tonight's subject is talking about subsidence and how it affects your wallet and other effects. To just summarize the other side of what we're presenting tonight, Simon Cicada, who's president of Quadvest, who is a large volume groundwater user and has a vested interest in using groundwater, did publish this. Not a single expert has ever supported the claim that water tables are dropping in Montgomery County. What everyone knows is that if you pump water from a well bore in an artesian aquifer, it will cause a drop in the water level, measured as a decrease in artesian pressure. As every expert will agree, he says, a drop in artesian pressure is not a drop in the water table. And he stated conclusively, the water tables in Montgomery County have not dropped. Samantha Reeder, who is the general manager of the Lone Star Groundwater Conservation District, stated just a couple months ago at a Groundwater Management Area 14 board meeting, and GMA 14 has jurisdiction over Lone Star. She stated, first, remaining available drawdown was a limiting factor in modeling, such that a subsidence metric is not necessary or meaningful in terms of developing a defined future condition, which we'll hear a little bit more about very shortly. Second, Lone Star objects to a subsidence DFC statement because there are other impacts outside of Lone Star's control. For example, she said, impacts can be felt in Montgomery County from groundwater pumping in Harris County. Well, let me turn it over to the three experts that are featured of our presentation tonight. And we'll start with Mike Turco. Mike, it's all yours.
Thanks, Bob. I appreciate that and appreciate the introduction. I'm happy to be here with you all tonight. And you know, one of the things that I've talked quite a bit about here over the last 10 years or so is the increase in the occurrence of subsidence in some areas of our region. Subsidence is obviously our mission objective at the Harris-Gallatin Subsidence District. And what I'm going to go through today is just a few things about subsidence, kind of give you some background on what it actually is, how it occurs. We'll look at some actual data from the U.S. Geological Survey.
Hey, Mike, can you hear me? This is Ted.
Yeah, go ahead.
Mike, you got a lot of static in your microphone. There's a lot of static coming through.
Okay. Let me see if I can fix that real quick.
Now we can't hear you at all, Mike. There you go. Now you're live.
How about now?
Now the static's back.
That's better or worse?
A little better. Go ahead, Mike.
Can I get a thumbs up from anybody that you can hear me?
Much better.
Okay.
Great.
All right, cool. Thanks. All right, great. So as we talk about subsidence, one of the things that we want to try to remember is the mechanism by which it works. And this works throughout the Gulf Coast aquifer. Our aquifer is a interbedded sand and clay. I describe it for the geologists that are on the call today. It's homogeneous and heterogeneity, and what that means for the rest of us is that it's equally reworked and remixed everywhere. The clay lenses aren't laterally extensive. They don't extend for a long period. They're not particularly thick. They pinch out and occur without a whole lot of rhyme or reason. But they're really important. It's the clay in the aquifer that we're concerned with, and that artesian pressure is really important for our system because when these clay lenses were deposited, they were deposited during flooding events, and they were under a lot of pressure. And prior to any development in our area, any groundwater development, those clay grains in those clay lenses were all randomly orientated. And as this schematic shows from the USGS, as you begin to depressurize those clay lenses will lay down flat. And it's that compaction of the clay lenses that we see at the surface as subsidence. Now, there are two primary types of subsidence that we see in this area. There's elastic and inelastic. The elastic subsidence that we see, or elastic compaction that we see in the area is kind of the things that you see in the shrink swell of the clay down near the coast and really impact foundations and sidewalks, but it's really close to the surface and more as an indicative of short-term changes in climate. It's the inelastic part, the part that occurs at depth as a result of groundwater withdrawal or shallow fluid withdrawal. That is really the most devastating part of that for us. It's by far the largest component of the overall subsidence that we see. I have some pictures on the slide to kind of show you some of the impacts that we've seen in the area. The black and white photo in the middle is from Goose Creek oil field. That's down near Baytown. That was the first documented case where USGS actually was able to link shallow fluid withdrawal in that area to subsidence in Goose Creek oil field. About 3 feet of subsidence occurred in 8 years, which for our area is a very fast rate. And then a protruding well there to the right is also from Baytown. And it looks like that well's been pushed up out of the ground, but what you're actually seeing there is the land surface having subsided around that casing, and actually see a land surface elevation loss. And then, as you might imagine, in our area, because we have a relatively flat topography, and water has a hard time to know where to move when it's flat anyway. You start changing drainage patterns by having localized areas of subsidence, you can have a big impact on the occurrence of flooding and the magnitude of flooding. And we've seen that here recently. That picture there is from Hurricane Harvey. Obviously, Hurricane Harvey is an anomaly in our area, but there's been a Tax Day flood, the Memorial Day flood, lots of other floods here recently. And as we look at our changing climate, we can only assume that we're going to get similar events in the future. So important things to consider. Now, we also we collect water level data and we measure subsidence throughout the region. We've had a long-standing relationship with the U.S. Geological Survey. And this is actually what I'm going to show you here next. There's a few slides that shows the Jasper Aquifer water level over time on a map scale. And it's important to note this is a multi-agency project. It's not only the Subsidence District and then the USGS, but also the City of Houston, the Fort Bend Subsidence District, the Peoria County Groundwater Conservation District, and the Lone Star Groundwater Conservation District all work together to collect this data throughout the region. And if you go to this website, if you don't want to write this down, you don't have to. You can just go to Google and search USGS Texas subsidence. This will be one of the top 3 things you see on that page. You can click on it. And you can explore the data and all of the subsidence data and that we collect. USGS has put up there. There's water level data that goes back throughout the period of record that you can look at. And one of the things that we want to look at when we're looking at this type of information is the potentiometric surface. You saw a quote earlier that Bob put up there that talked about water level and artesian pressure and all that. And there's some nomenclature semantics going on there. The reality is that the pressure in the system is important. The water level in these wells is important when it's compared to where your pump is or how deep your well is. All that plays into that, and it has a big impact on compaction and subsidence. So what we're looking at here is the water level in wells that were open to the Jasper Aquifer in 2010, measured by the USGS and published by them back in 2011. And all of this is USGS data. And what we're looking at here is the potentiometric surface. So it's not this is an elevation. It's not a change map. So you're looking at the actual elevation of the potentiometric surface or the water level in the aquifer. And as you can see, the lowest point in the Jasper in 2010 was centered just north of the Woodlands, just right there, kind of on top of the Woodlands, and where all those triangles pointing down are. Those triangles, by the way, are the 5-year change in water level at those sites. And as we go through time, we can go forward to 2015, and you can see that now, whereas in 2010 we had just a little area of a minus 200. If we go to 2010 or 2015, now we've got a much broader area where the elevation is now above or below 200 feet, below sea level, and so we're seeing the impacts of water level decline over time in that potentiometric surface data. And then if we fast forward to 2019, we can see how that's shifted now and broadened out. We've seen changes in regulation, different patterns in water management in the area. All those triangles now are pointing up, and water levels have begun to rise. And we're beginning to see the impacts of that. Now that 200 is kind of focused there in just one small area in northern Harris County. And then if we move on to 2020, we can see that it's kind of expanded here again. We watch these annually, and this is a really good indication of, one, the impact of pumpage in Montgomery County on the Jasper Aquifer, and you can see the same story being shown in the Evangeline Aquifer as well. But this helps us better understand the impact and the interplay between pumpage in the area, and give us an idea of where to look for when we look at stresses on the aquifer and where we might want to monitor and be looking for subsidence in the future. One of the ways that we monitor subsidence is through these GPS sites. Here's an example of one that's down near our office in Friendswood. We have about 225 of these stations now throughout the area. This is a cooperative effort that we do with the University of Houston. In fact, the University of Houston actually publishes all of the data from these sites and processes all of the raw GPS data. This information gives us the total amount of movement at land surface, up, down, and XY, because we get all movement of the benchmark that's about 30 feet below land surface there in the picture that you see. So we can't determine from these sites where in the aquifer the compaction is occurring, but we can tell you how much subsidence has occurred at these sites, and that's really important for us to be able to begin making the connection between changes in water level, changes in water use, and changes in subsidence. Now, one way that you can get to identifying where in the aquifer that compaction might be occurring is by the use of an extensometer. We have 12 locations and 14 extensometers throughout the two districts in Fort Bend and Harris Galveston. They're a little bit different than that, and they're a little bit more expensive. But what they do is that they actually have a benchmark placed very deep in the aquifer. They have slip joints on an inner casing, and then you can measure reference points between an inner casing and an inner stem to very, very discreetly measure how much compaction has occurred over the interval of the extensometer. And they're very useful data. If you're interested in more in that, let me know, and certainly I can point you to some of our data on our website that shows how that data looks. But here's what our monitoring network looks like. And this is all the information that you see here on these next two slides is going to be provisional because we're in the process of finalizing the publication from last year. We'll have a hearing at the end of April, and then shortly after that, all of these provisional stamps will come off. But I wanted to share up-to-date information with you tonight. What you see on these data points is that the bigger the circle, the warmer the color, the faster the subsidence rate of those locations. Now, what you see on the map is areas 1, areas 2, and area 3 are denoted on the map. What that's showing you are our regulatory areas. We regulate as a percentage of total water demand. So, for example, in area 1, you can utilize groundwater as 10% of your total water demand. right now. In area 2, you can use it for 20%. And in area 3, which is northern Harris County and western Harris County, you can utilize it for 20% of your total water demand. Or if you're in a groundwater reduction plan, you have a process by which you're reducing from 100% groundwater to 20% by 2035. So that whole area went through a conversion in 2010. They went from 100% to 70% groundwater. In 2025, they're going to be further converted to 40% groundwater. And then in 2035, they'll be at the final conversion at 20%. So that's how that conversion process goes. And you can see in areas 1 and 2 the results of how that works. Those areas right there are areas where we had the highest amount of historical subsidence occur in the entire region. Over near Baytown, upwards of 9 feet of subsidence that occurred. And those areas now are generally stable, and they continue to be that way. So the conversion process and the regulatory plan, the way that the district has set it up in the 1970s, 80s, and modified in the 90s, and then again in 2010, really has produced high quality results. And we continue to move down that road to see that. If you want to zoom in more into the northern and southern Montgomery County area, you can see the sites that we have in Montgomery County. So these sites are either operated entirely by the district, or they're operated in cooperation with the Lone Star Groundwater Conservation District or the University of Houston. There's several in here, and I don't denote here which ones are which, but PAM 13 is P013 in here in the middle. That's one that we operate. And if you want to look at how that period of record might look, it really tells an interesting story of how subsidence has occurred in our area, in southern Montgomery County. This is what the actual data looks like after it's processed. On the y-axis, you have change in ellipsoid height or subsidence in centimeters. And this is the entire period of record, goes all the way back to 2001. And you can see that the rate of subsidence was relatively consistent all throughout the period of record, going back from 2001 up until around 2015, when the surface water plant came online and water management practices were changed at PAM 13. The rate switched from about 2 centimeters per year to about 0.5 centimeter per year or less. And it stayed relatively stable up until about 2020, late 2019. And there is a short-term downturn here that may be indicative of some recent changes in water management in the area. Something that's worth watching, and that certainly we're watching from our perspective. But just give you an example of what that data looks like, and the results of diversification of source water and utilizing that as a method to prevent subsidence. PAM 13 is a really good example of that. I do want to mention just a couple things that the district's currently working on. We have a joint regulatory plan review in progress right now. That's a joint project between the Harris Galveston and the Fort Bend subsidence districts. And we're developing population projections and projected water needs, not only for Harris, Galveston, and Fort Bend, but for Brazoria and Montgomery County and the other adjacent counties that we have. And we're doing that because we want to make sure that we best understand the needs and the water needs for the entire region. It's a multifaceted project that has updated groundwater flow models, looking at long-term supply and alternative water supply availability, development of various scenarios, including looking at climate, and how we will utilize that information and better make sure that our regulatory plan meets our mission objectives. We're also looking at other science and research projects in the district. One of those is the Spring Creek subsidence study. Right now, we began in January 2020. 2021. We began a project on Spring Creek to look at the impact of increased subsidence on flooding on Spring Creek. We're utilizing the latest MapNext model in cooperation or collaboration with Harris County Flood Control. We'll run several scenarios through that model to evaluate the impact of subsidence on flooding, and we're planning on having results on that early in 2022. So we're looking forward to that project. We're also doing some work with SMU on INSAR. INSAR allows us to look at subsidence in between the dots, and we'll have more results on that later on this year, and it's very promising technology for us. So here's our website. I hope everybody has a chance to go check it out. There's a lot of good information on there. There's things you can sign up for to get more information. And with that, here's my contact information and my Deputy General Manager, Dr. Peter Peterson. Please feel free to reach out, either one of us, if you have any questions. And with that, I will turn it over to Ron.
Hey, thank you. Can everybody see my screen? Okay.
Yes, sir. Looks good.
Great. Thank you for this opportunity to visit with you today. I have basically two subjects. One is about to give you information that we measure every 6 months in the Woodlands, and then also some information about GMA 14 and the DFCs. The Estuary Woodlands owns and operates 38 groundwater wells in the Woodlands. There are 18 in the Evangeline, and there are about 20 of them in the deeper Jasper zone. Over the last 30 years, what we do is we measure the depth of the water from the ground, or for the top of the casing in each well. And here's the data that we've collected over that 30 years. And as you can see, this is from the Evangeline. As you can see from the left-hand side of the chart to the right-hand side of the chart, there's been a steady decline of the aquifer level, of the water level in the wells over time, because there's been a greater use or pumpage. As the Woodlands grew, there were more people drinking water, and so there was more pumpage. As you can see, about 2015, there was a rebound or bounce up, and I'll have a more detailed drawing of that for you in just a minute. Same can be said for the upper Jasper. Also measured the water from the ground level down to the water elevation in our wells. These are taken, like I said, every 6 months, and the same pattern over 35 years. It was dropping down, and then once we started introducing surface water, you can see there was a bounce up, and I'll get more specific in this slide here. This is the combination of some Jasper wells and some Evangeline wells. You can see in 2015, late 2015, when we started supplying 65% surface water to the Woodlands and 35% groundwater, you saw there was a bump up, or we call it a rebound, in the levels in our wells. That bump up kind of stayed flat. In the mid to 2017, we moved over to a 50% surface water and 50% groundwater. You can see it still stayed relatively flat. Then in 2019, for budgetary reasons, we reduced the capacity of the plant, or we reduced the production out of the plant. And you can see where there was a drop off in the wells. Again, the aquifer level, it started dropping because we were using now more groundwater and using less surface water. So now the aquifer level started dropping in the wells. Concurrently, Mike has shown you this map. This is a location of all the PAM sites and Port of Measures that are in the Woodlands. And you can see there, we also have a plot of the Woodlands wells. And Mike showed you the full record of the PAM site 13, and this just shows you the last 10 years. That as he showed you, in 2010 through 2015, there was a downward trend, or an increase, continually increasing in subsidence in the area, in the Woodlands. Then when we started using surface water in the Woodlands in late 2015, at 65% surface water, less groundwater, you can see that the subsidence leveled off. Just like the water levels in the wells, the subsidence, land subsidence leveled off. And you can also see that once we moved, and Mike showed you this information also, once we moved to a 35% surface water and a 65% groundwater. So pumping more groundwater, you started to see more of subsidence occurring in the area at this particular location. And that also coincides with the dropping of the aquifer in the wells at the same location. And so there's you can take the correlation there however you would like to interpret it, but it looks like there's a direct correlation between the aquifer levels and the subsidence. And so the other subject I'd like to cover real quickly is the GMA 14. A lot of you have probably heard about the GMA 14. A lot of you probably have participated in the GMA 14 meetings. The groundwater management area 14 basically goes from the Sabine River over to Washington County, from the Gulf of Mexico up north of us into Livingston and Huntsville. And there are 5 voting members, groundwater conservation districts within the GMA 14. And the Lone Star is one of those 5. Now there's also 2 subsidence districts, the Harris Galveston, which Mike is the general manager of, and then the Fort Bend. But the voting members are these 5 groundwater conservation districts that are shown on this map. For the last couple of years, and every 5 years, they go through a process to define the desired future conditions. And basically what that means is, what do you want the desired condition of the groundwater resources in your area to be over a specific period of time? Basically setting goals. And so in the state law, the definition of desired future condition is also, it must provide a balance between groundwater production and also the conservation and preservation, recharge of groundwater and subsidence. That there must be this balance between, if you take more groundwater out, if that causes more subsidence, there is a balance. There's a price to be paid, and vice versa. And so that the state law requires you to look at what that balance is, but it doesn't define how you determine what that balance is. That balance has to be determined by the people, the 5 voting members of the groundwater conservation districts that are in GMA 14. Through this process of evaluating the desired future conditions, the members of the groundwater conservation districts in GMA 14 have looked at 9 factors that they're required to by state law to look at. And you can see them here on your screen. They're looking at water supply needs and environmental impacts. They have to look at subsidence and the impact subsidence has on, again, groundwater pumpage. They have to look at property rights and a variety of other factors in this. And they have to, when they're all said and done, they have to take these 9 factors and the results of their studies that they've done for the last couple of years. And as I said before, come up with that balance between producing groundwater and these 9 and the impacts of these 9 factors. Well, the groundwater management area 14 have narrowed down to 3 different scenarios of desired future conditions. And to put it very simply, it's how much groundwater do they want to be able to pump out, and what are the effects or impacts on the aquifers. And they're looking at 3 scenarios, and simply stated, those 3 scenarios are that for Montgomery County is Montgomery County using 115,000 acre feet per year, or another scenario is Montgomery County using 97,000 acre feet per year, or Montgomery County using approximately 61,000 acre feet per year. Now, that's I won't get technical, but that's a result of a modeling effort. The actual desired future condition is, where do you want the aquifer level to be, and also how much subsidence are you willing to allow in the area. But the result of that DFC comes up with those 3 simple basic numbers. And for those of you who may remember, the former Lone Star board criteria or rules prior to last year was to limit pumping in the Montgomery County to 64,000 acre feet per year. So you can compare that to where we were to the three scenarios that are being considered now. And another important thing to consider is what is the future demand? I know Bob had some charts on looking at what historically was the future water demand in the county and also population data. And what this is the Water Development Board every 5 years also does a regional water plan. And the 2021 regional water plan, these are the projections. And they projected that in 2020 that the water demand in the entire county, total water demand was about 115,000. I think it was a little less than that. But by 2030, in just 9 more years, we would be at 140,000 acre feet. And by 2070, we would be near 300,000 acre feet. So remember those numbers of primarily the 140 that I have circled in red for 2030. And you can compare that to those three scenarios that they're looking at for the desired future conditions, 115, 97, and 61. All of those numbers are less than what the projected water demand is going to be in the county in just 9 short years. The other thing that the groundwater conservation districts of GMA 14 did is their consultant did some modeling of what the projected additional subsidence would be in the area for each one of those three scenarios. And this is kind of a plot of what that additional subsidence would be. Now, this is over a 70-year period of time, okay? So the little red lines are like contour maps. And so you can see in this plot at 115,000 acre feet per year in the Woodlands area, it ranges from somewhere around 1.75 feet to about a foot of additional subsidence in this area over the next 70 years. If you look into eastern Montgomery County, it's closer to 3.75 feet of additional subsidence as a result of pumping 115,000 acre feet of groundwater out of the wells in Montgomery County. If you look at 97,000 acre feet, you can see where it's only about a foot and a half, 1 to 1.5 foot in the Woodlands. So there's a direct correlation there too, is you're pumping less groundwater, which is resulting into less projected additional subsidence. If you look at the third scenario of 61,000 acre feet, you can see where the additional projected subsidence is anywhere from 1.25 to about a half a foot in Montgomery County, and it's a couple of feet in eastern Montgomery County. And one of the things to note that we won't get into details, but one of the things in this model that they use is the Jasper, the compaction and the subsidence from the Jasper I'll guess a simple way of saying it is turned down. That correlation in the model is turned down. And I think one of the things that Mike's group is going to be doing in the future model come out in 2022 or 2023 will be to address that issue. So you can see that there's a correlation there between, in our own wells, you can see there's a correlation between more water demand, lowering of the aquifer levels in those wells, and then additional subsidence. And then you can see what the impacts of those additional desired future conditions that the GMA 14 is considering, and what their potential impacts may be long-term on subsidence. So what is the process involved? GMA 14 has to, by the state law, has to approve, this group of 5 has to vote and approve of a set of desired future conditions by May 1st of this year. They actually have a meeting this Friday in which they will consider voting for one of those 3 scenarios, or they could choose something in between. Once that is done, once this group GMA 14 votes on it, and it must be a 2/3 vote, so there's 5 groundwater conservation districts, so 4 of them have to agree on which scenario they're going to choose. Then that scenario gets sent back to each of the individual groundwater conservation districts for a 90-day public comment period and a public hearing. So Once GMA 14 votes on a desired future condition, it's going to go back to like our own Lone Star, and they will have to have a 90-day public comment period and a public hearing on the desired future condition. And the public will have the opportunity to say if they like it, they don't like it, it's feasible, it's not feasible, whatever you choose to do. Then each of these groundwater conservation, and the other 4 will do the same thing. Each groundwater conservation district then will prepare a summary of all the comments, and they will then vote on whether or not they want to make proposed changes, they want to accept it or not accept it, and then they will reconvene as a group. These 5 groundwater conservation districts will reconvene as a group later this year, and they will finalize what their desired future conditions will be, and that vote has to occur before January 5th of 2022. So likely it'll occur sometime this December. Once that final approval of the DFC occurs, then the districts will be required to then implement whatever that DFC is by developing a groundwater management plan and then some rules to support that groundwater management plan so that they can achieve those desired future conditions of the aquifer. And that's all I have, and I'll turn it over to Bob.
Jim Stinson.
Jim Stinson.
So Jim, you're muted.
Okay, I'm trying to get my, there we go.
Okay.
Okay, can you see my screen and hear me okay?
Yes, sir.
All right, very good. I'm going to talk about an recent effort to bring in a third-party independent group of scientists to talk about subsidence and groundwater withdrawal. If you've been following this topic for any time, you probably understand and have seen that there's kind of a debate and a disagreement going on with scientists in the community regarding the impacts of groundwater withdrawal and subsidence. So I have been working with an effort to bring in a third party into what I call an independent group of scientists to look at this topic. And with the Houston Advanced Research Center, we put together a regional groundwater science partnership. This will provide science-based review as well as community outreach on regional data and studies relating to groundwater supply, demand, and subsidence in Montgomery County. This effort is being driven by a groundwater research consortium. This consortium provides financial support to develop this independent science-based groundwater and subsidence research and data analysis. The consortium also includes a science advisory committee. The consortium members are Montgomery County Water Control and Improvement District Number 1, Southern Montgomery County MUD, the Woodlands Township, and the Woodlands Water Agency and the 10 MUDs that it serves. We currently hold quarterly meetings. These meetings are held independent of the Science Advisory Committee, and our findings are provided to local decision makers and the general public. The project manager for the consortium is the Houston Advanced Research Center, and for more information, I would encourage you to visit their website. The Science Advisory Committee recently undertook a review of a Lone Star Groundwater Conservation District Subsidence Investigation Phase 1 report. The Science Advisory Committee findings were that they have concerns that the Lone Star report suggests Harris County is responsible for 80 to 90% of subsidence in Montgomery County. They have a concern with that finding. The Phase 1 report focuses on the Houston-Galveston region. The Science Advisory Committee recommends that further studies should focus on Montgomery County. In particular, the historical subsidence data that's available for Montgomery County and consider the reduced subsidence and fault movement since the introduction of surface water. We've seen some data on that correlation. And the Jasper aquifer compaction. There is a disagreement and debate on how the Jasper withdrawal or groundwater use from the Jasper impacts compaction and subsidence in the area. The Science Advisory Committee also has some recommendations for what is labeled a proposed 2 study or phase 2 proposed study by Lone Star on subsidence. The Science Advisory Committee recommends that we install at least 20 continuous GPS stations co-located with Jasper aquifer wells. They suggest that about 3 years of data will provide new insights into subsidence. Also, they recommend that we install an extensometer in the Jasper aquifer. I think Mike Turco talked about extensometers. They are a device that really can accurately measure subsidence or compaction at deeper levels than the GPS monitoring station. So we need an extensometer somewhere north of the Woodlands in the Jasper to provide some reliable data on that aquifer compaction. They also found that the phase 1 report by Lone Star states that the phase 2 should study subsidence and flooding. The Science Advisory Committee recommends closely following the just now beginning study that Mike talked about with the Subsidence District and the Flood Control District on Spring Creek subsidence and flood study. They recommend that these methods and results can help Montgomery County understand the impacts of subsidence on flooding. And that's my brief presentation tonight.
Well, thank you, Jim. Let me conclude here. I think we've heard from 3 experts on the concerns that a lot of us have about subsidence in the Woodlands and Montgomery County. And there are a lot of people that may be tuned in to this presentation whose homes flooded by less than a foot, and you can blame all of it on subsidence. But let me summarize the conclusions that I've drawn from this presentation. Is number 1, declines in water tables conclusively causes subsidence. And we can't blame it all on Harris County, because as the report shows, that subsidence is most closely affected in the areas surrounding where groundwater is pumped. However, there still are conflicting opinions on what additional pumping is sustainable without causing subsidence. More importantly, is subsidence cannot be reversed and contributes to more flooding. There are a lot of people who won't disagree with that. It also causes disturbances in fault lines, as even the head of our township board can testify. And it leads to problems with the existing wells by either having to modify them, collapses in casings, or even replacing existing wells, or spending more money to pipe water up much greater distances. More groundwater pumpage will increase water rates to those that use surface water, simply because the very high fixed cost of the surface water plant at Lake Conroe will be shared by fewer users. So they must share an increased burden of retiring the investment that was made. And finally, there's more than enough surface water to meet water demand. So why do we need to pump more groundwater? Okay, I'm trying to go down and okay. What can residents do? Well, first of all, is to understand the facts and alternative viewpoints. You can attend or review recorded videos of the Lone Star board meetings. And I think that'll be a revelation to everyone. To let the Lone Star board know of your concerns. To let Groundwater Management Area 14 board know of your concerns. And finally, add your name to the petition posted on our Township Future website, the link shown here, and go to the tab that says Sign Our Petition, asking GMA to limit Lone Star's desired future conditions so that no further declines in aquifer water levels and subsidence occurs in Montgomery County. And I think that concludes our presentation, and we're ready for questions. So I'm going to turn it back over to Ted. Ted?
Thank you, gentlemen, very much. Appreciate it. You all did a tremendous job. We do have a few questions. Bob, the first one would come from one of your slides initially, I believe. It says, what is the date of the Sequoia quote? I'm probably not pronouncing that right, but in one of your slides, you were
That was on the Golden Hammer website by Eric Yellick. There was a discussion between Laura Norton on subsidence, and at that point, Simon Cicada rebutted what Norm had said. I think it was only like 2-3 weeks ago, and I'd be happy to provide more the full quote. I have to summarize it because it was fairly long, but it was taken directly from Simon Cicada's submittal to the website.
Okay, so we'll get the date and post the answer directly to that question. One of the other questions, I think you probably all, the panelists can see it, but let me just read it very quickly. I believe that the work that was done at Cathedral Lakes next to Grace Church, where the new Lexus dealership was built, was a factor in the flooding of Grogan's Point during Hurricane Harvey. Before Harvey, the northeastern side of I-45 of Spring Creek wasn't filled in, and the amount of water that could flow through under I-45 was twice versus what it is today. Has there ever been a study to research if this may have been a factor? Any of you know whether that may have been, there was a research done that
My recollection
may have
is
been a
that
factor for the flooding of?
my recollection is that there was an analysis done by the MUDs, and that the finding was that the cross-sectional area underneath I-45 upstream of that dealership was the limiting factor rather than any new construction downstream. But I can verify that.
Okay, thank you. The next question says, does the San Jacinto Lake Conroe actually have enough capacity for the nearly 300,000 acre feet you're projecting will be needed by 2070? If not, where would that water come from except from deep freshwater source?
No, there's not. Lake Conroe has a firm yield of about 100,000 acre feet. The estuary does have 50,000 acre feet optioned in the Trinity. If needed, that would be, long-term, 40, 50 years from now. And actually that's going to be under discussion later this summer.
Okay, so we'll look forward to that. There's a question that says, excellent presentation by everyone. Thank you for clearing up this confusing issue. Has anyone picked up the baton that the new LSGW dropped with respect to settling withdrawal rates, i.e. cannot the Woodlands water or other reopen the suit that was, to my thinking at least, fraudulently settled after the election that was set for the, I don't know if any one of you can pick up on that, if that was just kind of a more of an opinion stated.
Ted, you may want to repeat that.
Okay, so we'll go back and
cut out.
Yeah, it was kind of lengthy, so let me see. It's an excellent presentation by everyone. Thank you for clearing up this confusing issue. Has anyone picked up the baton that the new LSGWD dropped with respect to settling withdrawal rates, i.e. cannot the Woodlands Water or others reopen the suit that was, in this writer's opinion, fraudulently settled after the election that was set up on the new board?
So legal question, somebody, a lawyer would have to answer.
Yeah, okay. Yeah, we'll have to figure that out, but we'll also post that. The next question says, do the other PAM sites show the same response to SW use as the PAM 13?
So when you look at, thank you for the question, and give me a thumbs up that you can hear me better this time. Are we good out there?
Sounds good from here.
Okay, great. Thank you for the question. So the one thing about the PAM sites, and the reason why we show rates and not period of record cumulative change, is because all those sites went in at different times. PAM 13 is unique in that it's actually covers the period of record before, during, and after a diversification in source water that we saw in the Woodlands. Some of the U of H sites went in right before the conversion occurred, so they don't have the same period of record. But in sites that are outside of areas that have received surface water, what we see there is really no change in the rates. Now, the rates may be a little bit slower or a little bit faster depending upon where you're at, but in the areas where you've seen diversification change and water supplies being utilized outside of groundwater, other than groundwater, we see an inflection and over that period of record. But in the ones that didn't have that change, we don't see a remarkable change in the rate.
Okay. We do have a couple other questions. Unfortunately, we're out of time. We didn't want to keep everyone too long tonight. So we will get to the rest of those questions. We'll post those on our website, and we'll go back and pick up the other couple that we weren't able to answer clearly in this discussion tonight. So we will get that done for you. So please check out our website for the answers to that. And we joining us tonight. As soon as we are able to, we do plan our presentations in person. So hopefully when we do more presentations like this, we'll be able to do those in person rather than by Zoom. And we apologize for the technical difficulties. We had a perfect run yesterday when we did a trial run. Practice was perfect. No technology whatsoever, no issues. So as you likely know, the Township Future was founded on three. Yes.
I'd like to add that the recording of the
Still
presentation
breaking up.
will be up on our website, as well as copies of the slides that the presenters made. So that will be available soon.
Perfect. So am I still breaking up as I'm talking? All right, so let me just say thanks to everyone for being on here tonight. Please go to our website. We can certainly use your help. Please consider supporting us with either financial donations or your physical volunteering, or join us for our grassroots effort to grow our organization. We appreciate everyone being on the Zoom meeting tonight. We especially thank our presenters who did an excellent job